Hope you are doing well. I'm just starting to feel a little bit sleepy, so hopefully we'll wake up with some puzzles, and we get to wake up with a full deck and missing a few cards puzzle, or a missing deck puzzle, is I learned their preferred collective noun, to abbreviate it, since they set a lot of puzzles together. So saying this, also, if you don't watch the Invitation to Puzzles series, they feature on the Invitation to Puzzles series a lot, because they tend to set very nice. Not to say they set exclusively introductory puzzles, but they set a lot of very nice introductory puzzles, which are good for that series. Speaking of, if you have nice introductory puzzles laying around that you would like to see on the Invitation to Puzzles series, you can submit them on Discord. Phoenix Aki did that, and I just recorded, I don't know, a dozen or so Phoenix Aki puzzles, which are great. So if you have those, and keep in mind, the series covers both pencil puzzles and Sudoku. So if you have introductory Heiawake puzzles or introductory whatever types of puzzles, I'm happy to see them. Every once in a while, even, I do puzzles of genres that I've never even done before, which is fun and cool. But at the moment, the setter group is not as diverse as it perhaps could be. By the way, Isaiah and Nell, I know, are doing some sort of Heiawake thing. Would you like to plug the time and place of that in chat? You're welcome to advertise it. I know it's sometime in the some future. Let's see. And then I also have coming up, I agreed to set some puzzle in a series with Nell, so we can look forward to, I'll probably do that on stream at some point. Okay, so let's look at this puzzle. So by the way, this is the most voted on puzzle by supporters. This is voted for by David, Plonktime, Russ, Ambrose, Nell, and Luda. So thank you all for your support. Alrighty, so we have killer cages that give the sums of the digits in the cages, and the digits don't repeat within the cages. And then we have these lines which are simultaneously zippers and modular lines. And the zippers and modular lines are the... I don't know how it sort of came out blue and purple, but we'll deal with it. So we need to make sure that every set of three things has a different remainder when divided by 3. So if you want, you can think of that as columns of your number pad. So 147, 258, 369. And so we need to think about that. And so we can, for example, think about this digit to start with, which is the sum of these two by zipper. So neither of these two can be 369. And so this has to be 369. Because if either of these were 369, then this would have the same modularity as the other one. So we can actually sort of percolate this 369 into those spots. Well, we're not putting 9s in our sum for sure. The sum definitely isn't 3 because of that. So this is either 3 and 3 equals 6 or 3 and 6 equals 9. Those are the options. Technically, we know one of these is a 3, so we know that digit is not a 3, and that digit is not a 3. Okay, so yeah, these two are A147 and A258. Let's see. Is it exciting if I fill in this? Yeah, I guess I know what modularity this is, right? Because this number here is just by math, it's either 5 or 8. And so I can just percolate that down to say that this is 258. And likewise, this number is either 1 or 4, and so I can just percolate that down to say that this is 1, 4, or 7. Like that. Let's see. Uh, row 2, column 6, row 3, column 7. I don't think I quite see what's going on there. There's only a couple options for what this combination can be, but I don't know if we really want to try forcing that at the moment. Let's see. Your claim is that 2 plus 5 plus 8 isn't 12. It's a little case checky, but I will accept it. AFK. So AFK's claim here is that this is a sum of 3 digits that sums to a multiple of 3, and so there's only a couple ways to do that. Oh, right. Okay, yeah. So this is different, right? Yeah, sorry. So DWeb is right. DWeb has streamlined AFK's argument by noting that these two are different, and so one can always figure out that if these two are different, this has to be the third one. This is like if you have 2 cells in a 9 cage that you know are from 1 to 6. You know the third is from 1 to 6. So we could, if we wanted, I don't know if this is going to be useful or not, but we can try this kind of coloring here. Let's see. But I don't think that does anything, but it is of note that this is certainly one of each modularity. We can apply that same logic to know that these are one of each modularity, but I think that's somehow even less useful. Let's see. Unfortunately, 258 is 15, so I don't actually know that this 15 cage... Actually, I do know this 15 cage isn't 258. Maybe that's what I'm supposed to do. So this 15 cage can't be 258 because it would break the modular line, actually. So we have one of each in here. I'm just thinking through, trying to think if there's some clever way we can use that. Because, like, it means these 3 are also one of each, but I don't think that's helpful right away. Yeah, a 12 cage can absolutely be 147. Unless it has a 258 in it. That's the only reason why this one couldn't. These other 12 cages could be 147, yeah. Although, funnily enough, neither of these can be 147 for the reason that if one was 147, the other would be impossible. So yeah, the thing I was looking at was if this is a 9, then that cell can't be 3, 6, or 9, but that still doesn't feel interesting. If this is a 6, I do consume some small digits down here. Let's see. I feel like it's probably not a 6, but it could be. So what is this sum if this is a 6? So it'd be 12 plus 15 is 27. So then these would need to sum to 18. They would have a 3 in them by sudoku. So if that's a 6, these would be a 3 and 2 digits that added to 15, which would have to be 7 and 8. So this would have to be, in the universe where this is a 6, this is 3, 7, 8. It's exactly. I don't see anything remarkable about that. Let's see. Do I just know how this has to work just on the basis of the fact that it's modular? No, right? These two have the same sum as these two. It always works. Yeah, I was a little afraid of that. I can at least pencil in the same deduction that I made over here. Like, these are definitely 3, 6, 9. Oops. That's not at all 3, 6, 9. Because of the same argument that this is the same sum as the sum of two of these things, and that's not 3, and these aren't 9. So that actually gets me a 3, 6 pair in both the row and the column. So that's actually interesting. Yeah, I don't know why I filled it in on one zipper and didn't fill it in on the exact same zipper the other way around. But it's definitely useful. So looking at that tells me one of these is 3, 6, 9. Oh, yeah. Right. Yeah, now they're both 9 sums, right? Because we now can't put double 3 here without putting double 6 there. Right. So in fact, both sum to 9. That's adorable. And we'll bring out Zach for the 9 dance. Ba-boop-ba-doop. Woo! Ba-boop-ba-doop. Wah! Boop-boop-ba-doop. Wee! Ba-doop-boo-doop. Ba-doop-boo-ba-doop-boo-doop. Boop-boo-doop-boo. Wah! Thank you, Zach. Thank you. Okay, so these are genuinely 3, 6. Those are genuinely 3, 6. Okay, so this digit now is naked, not 147, not 3, 6. So this is now a naked 258 because it sees 3, 6, and 9, and it sees, well, it's not 147. So that makes that a 258. And now these are both from 3, 6, 9. And neither of them can be 9. These two probably have to be a 3, 6 pair. But maybe not. They could be 3, 3, I guess. Would be fine. At least-ish. Now, this has to be 3, 6, 9 because of the earlier point about this sum. These two sum to a multiple of 3, and 15 is a multiple of 3. I bet I can repeat that exact trick over here. This cell has to be a 147 because it sees 3, 6, 9, and it's not 258. So that's a 147. That's a 3, 6, 9. Just to fill that in. Yeah, we can color 3, 6s. That's not a bad idea. Let's see. We will catch up our 3, 6s. Like that. So this 14 cage doesn't have a 3 in it. Oh, right. We didn't actually fill in that these are 3, 6, which was just given, right? I filled in the other two. So we actually know which 3, 6. Oh, actually, sorry. Both of those are O. Both of those are OE36. So there's an OE36 in this 12 cage and an XE36 in this. No, sorry, that's not true. There is an OE36 in this one, but I somehow seem not to know that this one. Oh, the OE36 is just placed somehow. The X one. Oh, it's because I didn't ever mark that this is X. That's why. So the xy one just goes there. Okay. So we've got that. So there's a 9 down this diagonal somewhere. Yeah, I just had not marked this as x, which was what had thrown me for a loop. So these are the same 3, 6. So could be 3 and 3 or 6 and 6. And this could likewise be 3 and 3 or 6 and 6. Same idea. Oh, I see. Yes, yes, yes. Right. If these are 6 and 6, I was like, there's plenty of ways to make these sum to 12, which is true. However, that would make this a 0. So these are 3s. And these are 6s. Very nice. Okay, so let's fill in some digits that go with that, like that and that. Okay, so now we know this sum is 6, so therefore that's a 1. 3, 3. Okay, this is certainly not 7 or 8. That certainly is a 6 because we know these two sum to 6. Let's see. That is not a 5. In fact, it's an 8 because the sum of this line is 12. That's certainly not a 1. That's certainly not a 2, but these two sum to 12, so that one's definitely a 3. Let's see. That might be all the gimmies for now. Let's see. Do I know anything that's about these? Funnily enough, either this is a 3 or this is a 6, I guess is my Sudoku logical deduction there. Let's see. These two are from 1, 2, 4, 5. Okay, that's probably the point. So these two are from 1, 2, 4, 5 because they add to 6, but this one's not 1, 4, so this one's not 2 or 5. I guess that still doesn't quite bring me to the point of not full knowledge of the universe. But it's close. Let's see. I'm looking for cells that see like all of 258, for example. I guess I do know that the sum of these two is a minimum of 9. Hey, Missing Deck, how are you doing? And it's certainly not yeah, so this number is not 3 mod, or sorry, it's not 0 mod 3. Because if this number was 0 mod 3, these would be double 9. So we can't do that. So one of these is 0 mod 3. And whichever one it is, it's a 9. Because neither of these, so we could sort of say one of these things has to be 9. For sure. And then the other is something, who knows. Okay, so we can sort of crisscross this across boxes, crisscross this across boxes, and then note that that tells me that the only place in box 5 for 9 is here. So the same math argument here implies one of these needs to be 0 mod 3, and the only 0 mod 3 digit available is 9, so this digit is in fact a 9. I agree with that. These two, let's see, 12 plus 12 is 24, plus 9 is 33, so these two need to sum to 12. So they're either 4, 8, or 5, 7, I guess, is not super useful. Unless I really want to dig my claws in deeper than I, in fact, actually want to dig my claws in. Let's see. This row is in danger of getting just like random naked singles, so I'm going to pencil mark it. 2, 3, 4, 5, 6, 7, and 8. And likewise, this column is from 1 to 4, 5, 6, 7. Okay, however, this can't be a 1, nor can that be a 1, just on the basis of the fact that the total is at least 10, and this number can't be a 9. So I know neither of those is 1. So that does sort of give me a weird corner mark 1 here. Which I don't know if does very much, but it's true. 2 doesn't work either is a really good point. 2 doesn't work either because the opposite side could be at most 7. Sorry, no, it could be 8, right? 2 and 8 are the same modularity. So 2, 8 would go with 1, 9. Let's see. Josh claims this number isn't 2. Warkwalla claims this can't be 8. I don't think I see either of these things as being evident. I do see that. Oh, I see. This one can't be 2 because that one can't be 8. I see. Okay, I at least see that part. And this one can't be 2 because that one can't be 8. So actually, we do get our corner marked 2 running across the row by just virtue of places that can't be 8. And so that rules 2 out of this cell. That tells me that one of these is 2, just for the column. And so one of these is 8, because that's the minimum. So that's not an 8. Okay, so now where does 8 go in box 5 is the question. Can I put 8 with a 9 in a 15 cage that still has another cell? No. So the 8 now has to go there. It's the only place, which now means that these are the 1, 9 floating over here. So these two do in fact need to add to 8. Wait, yeah, these two have to add to 8. No, have to add to 10. Sorry, have to add to 10. So this can just never be 5. And it can't be 7 either. So this is the 8 with the 2 that we are looking for, which gives me the 5 and the 4 here. No, 5 and 1 there. That does add to 12. Yep, you're right. Let's see. That is a 4, 7. So we get all of that. This now can't be 5 anymore because we've just now left it so only 1, 4, 7s are left for this cell. So this just has to be a 7. And the only question is if this is summing to 14, which it can't, or less than 14. But if this summed to 14, that would be a 1, and we've already got the 1 corner marked. So indeed, these sum to 11, making them 2, 9 with a 3. With a 4. Sorry, I can do math, I swear. Which seems to make that a 1, a 7, a 9, a 1. We can solve for x here and get that. Okay, very nice. that was a lovely, string of deductions there. Okay, so now what shall we look for? Glad to see arithmetic is as much your friend as mine. Yeah, definitely. Yeah, people are always like, "Aren't you a math professor?" But I feel like anyone who knows math professors knows the arithmetic of the average math professor is poor. Okay, this cell can't be 1, 2, 3, 4. I think it can be 5. It can't be 6 or 7. I think it can be 8, and it can't be 9. So that gives me a weird 5-8 pair in the row, with which I don't know what I'm going to do. Who knows? What about this cell? Let's see. Can I do a similar thing? It's not 1, 2, 3. This one can be 4. It's not 5, 6. It can be 7, not 8 or 9. So that gives me a weird 4-7 pair here. Excellent. Oh, I'm being told that 5 in box 8 is yes, 5 in box 8 now. Because of the weird 5-8 pair, 5 in box 8 is now here. Okay. Emma says pencil mark box 5 or box 2. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see. That's not 8 or 9. That's not 8. It's not 9 either, if you consider that these numbers need to add to something. So these aren't 4 or 7. Those are an 8-9 pair, which gives me the 2 and the 9 in order. Let's see. 4 here would go with 5. 7 here would go with 2. Both of those seem legit. Let's see. 6 in box 1 due to Screaming Ice Cube logic. Oh, yeah. If we want to do, if we want to figure out the sum of these three, we did do this before. So these three sum to 18, plus 15 is 33. So these three sum to 12. And yeah, if I make this a 6, that's kind of ugly. Yeah, if I make this a 6, it doesn't work, but I'm not going to use it. Hey, Ratfinks, how are you doing? Yeah, we can spread this modularity. So now this is a 2, 5, 8. That's not an 8 just by sudoku. This 4, 7 tells me that this is a 4, 7 because it's not a 1 by sudoku. So that is very handy. Not too bad. Yeah, I'm also not too bad. I start my ridiculous J-term course tomorrow, so I'll be doing like 5 days a week, 3.5 hour days of teaching, which will be exhausting but fun. Let's see. Marking box 8 sounds like the thing that doesn't involve thinking about killer cages, so let's do that. We've got a 1, a 7, and a 9. That one's not a 1. That one's not a 9. The 1's over here. Oh, this one's not a 9 either for lots of reasons, actually. We can percolate that up here. So this is a 1 or a 7. Hey, Jay, how are you doing? These are from 2, 5, 8. That one's not a 5. Let's see. And this one actually can't be a 5 either because it would make that a 4. So we can do that. Oh, this has now become a 1, 7 pair. So that's just a 9. If we are so inclined. Let's see. So now there's a 9 in this 12 cage. Ooh, nice to hear it. I look forward to seeing what you create. So this is a 1, 2, 9 cage because of the fact that it has a 9 in it. In fact, the 9 is just placed, even better. The 1 in row 7 is now placed here by our Zach wing of 1s here that looks over and tells us that the 1 in row 7 has to be in one of these two places, but the 1 has to go there, so, or can't go there, so that is a 7 and a 2. gives me the 1 and the 2 like that, gives me the 5 and the 4 like that. Let's see, that is a 7 and a 1. That's a 2. Oh, I did that backwards. What did I do? What's the other way? I said 1 and put a 7. Right. This is 1. Right, sorry, yeah. This is 1 by Sudoku is what I argued, and then I wrote the wrong thing. I see. So that is 4, 7, 4, 5. Let's see. This row just has a pair of 6 and 7 in some undisclosed order. Let's see, what's left in this box, actually? It's 6, 7 in the other one, which seems to be 5, of which this one seems only able to be 6. So that all goes in. That goes in. Yeah, the fact that these 3 sum to 12 means these 2 are 2 and 3, AFK points out. I agree. And I think we can probably mark now, actually. So we get a 1, 8, 6, 9, 8, 9, 2, 1, 1, 7, 7, 1, 8, 2, 4, 5. Let's see. 2, 7, 4, 5. We will remark, as they say. So this is a 7 and a 4. Those need a 3 in order to add like that. And yes, that was quite lovely. Good voting by the lovely folks who support us on YouTube or Patreon and get to vote on what puzzle we start with. So thank you, Windmills. Great choice. The puzzle even looks kind of like a windmill, I suppose. A swirly windmill. But yeah, lovely logic here. I enjoyed that one quite a bit. All right, I'm going to take a quick break, and I'll be back with another puzzle in just a moment. So see everyone in just a moment. Welcome back, everyone. We have a Matt Trussell puzzle here next. Isaiah asked if there's a new FullDeck puzzle every day on LMD. No, but there is a new one every day on their website, which is far nicer than LMD. I don't think it is controversial to say. Okay, so let's have a look at this. So each constraint type may contain no repeated digits anywhere in the puzzle. And I always enjoy puzzles with that rule. And entropy lines, every set of 4 adjacent digits on one of these lines must contain a digit from each X pair. Okay, and then we've got all the rest of it is normal. So there is this pattern on 5s, which is what immediately pops up for DWeb. And so the key thing here, oh, did the link not get pinned? It is pinned. And so the trick that shows up when you have one of these things, that I think is probably worth actually contemplating in a non-set way, because this pattern, people said this as, so like one way you can see this is totally valid in this instance but does not generalize well, is that none of these cells can be 5 because there's no 5 on the Fistemafel ring. But I think it's better to think about this as here are 2 columns, here are 2 rows. How many 5s do they contain? And we can count that in 2 ways. We can count it as this is 4 boxes worth of 5s, so there need to be 4 5s. Or we can count it as it's the number of 5s in yellow plus the number of 5s in blue minus the number of 5s in the overlap. Because if you have a 5 in one of these overlapping cells, you have the problem that it's now counted twice. And now the problem is that immediately gets you too few 5s in these cells. And so you'll see this show up in a lot of puzzles. I use this moderately often in my puzzles. And so the point is you immediately rule 5 out of these overlaps. In this particular instance, I agree that you could do it with just the Fistemafel ring, but in the interest of avoiding saying the words Fistemafel ring, that does. Jay Dyer suggests the simplest way to prove it is to brute force the puzzle and check what the digits are. That is probably true. Yeah. Okay. We do know this is at least 5. And so it's just a mutant fish, right? AFK. I think it's just a mutant fish. I do want to note that this number is at least 5 because there are 2 different ways to make it. Now, I will also go ahead and use the fact that is being suggested that I probably should have kept the coloring for, which is that, remember, I said that there had to be a 5 in this column in one of those cells, and there had to be a 5 in this column in one of these cells. So therefore, this Renbon doesn't have a 5, and this Renbon doesn't have a 5. So this one's just automatically 4, 5, 6. So this is 1, 2, 3, or 7, 8, 9. So she does look up and down. That's what I was looking at. I don't think that does anything. Well, this one's just not 1, 2, 3, right? Because if this one was 1, 2, 3, the arrows would both have to be 4, 5. So this is the one that's 7, 8, 9. This is the one that's 1, 2, 3. And so that actually brings this down to only being able to be 5 or 6. This number here is 1, 2, 3. Let's see. Okay, so I now know if I look where the 7, 8, 9 goes in this box, 2 of them can go on the whispers, but only 2. So the other goes over here. So this is from 5, 7, 8, 9 only, funnily enough. And likewise, oh no, sorry, not likewise over here. Likewise down here, actually, sorry. This 1, 2, 3, I can only shunt 2 of them on the German whispers. So the other one goes here. Oops, not all of those. So this is from 1, 2, 3, 5. Oh, there doesn't need to be a 5 in that domino. Right. Sorry, never mind. You're right. I am treating this like it's a usual corner mark, but it's not actually a usual corner mark. Yeah, this is certainly 7, 8, 9 worth noting. So how about we do that, and then we look down here and say, so the low digit on this is a 4. Or sorry, so the high digit on this is a 6. So therefore that's a 6. We'll do it that way. And that lets us bring out Zach for the 6y dance. Boop boop ba-doop. Whoop whoop whoop. Boop boop ba-doop. Whoop whoop whoop. Boop boop ba-doop ba-doop ba-doop. Thank you, Zach. Thank you. So that's a 6 next to a 1, next to a 7, 8, 9, next to a 2, 3, 4. Like that. So we have a 1, 9 over here in this column, because neither of these can be 1 or 9. They're not, sorry, the 10 lines are tentropy lines, not 10 lines, which fools me every time I look at it. But I have eventually come to accept it. I have a feeling this is going to be a 9, but I don't want to prove it unless I have to. I might have to. I'm not opposed to proving it if I have to. But we can do that. Okay, so we've got 2 of 7, 8, 9 here. We know these numbers are no larger than 5. For sure. Oh, 6 in box... 6 in column 3, it's being pointed out, is up here. So that means there's a 4 on this line, but the 4 doesn't go there. And that now means there's a 6 on this line down here, which goes there, because of this this whole idea. I agree with that. Oh yeah, I should probably scroll up so that rule on the capture on the screen is at the top. Yes, the sum of these digits is even because of region sum lines, whereas the sum of all the digits is odd. And the sum of all the digits is these numbers, which are even, plus triple this number. So this number has to be odd. So it's certainly 5, 7, or 9. I agree with that. But the 5 in the row has already been eaten alive by these 5s, correct? These aren't 10 lines. Emma Grant, they're tentropy lines. Right. This 6 sees all of these cells, but there's 9 total cells on region sum lines. So I agree that means that these are here. Oh, I see. Emma's talking about where 4, 6 goes on an X. And so one of these is 4, 6. because this x and this x aren't 4, 6. And there are, in fact, 4 x's in the grid, which I had not appreciated until now. If this is 4, 6, then funnily enough, it forces that to be a 4, because there's certainly not a 4 in these cells. Let's see. Oh, I could also notice this 4, 5, 6 triple. Thank you, AFK. So that's not a 4. So that's not a 9. And no, it doesn't work that way, but yes, it does work that way because we've had to use all the digits except 9. So the 9 on the German Whisper has to go next to the 4, which now is up here, which now means that this actually is a 4, 6. And this is a 4. Okay, so the 6 is not there. So one of these is a 6 for real. That's right. The 4, 5, 6 does eliminate the 5 pencil mark in each of those spots as well. So really, truly, one of these is 5. I think this is only a 2, 3. AFK agrees, I see. I do know one of these is a 9. I should probably mark. I don't know that it does anything yet, but sure, why not? So if this is a 9, then these are sums to 9. If this is a 7, that's 21, which means these sum to 24. That makes them sums to 12. I'm not super interested in pursuing that at the moment. Let's see. This has a 4 on one of the ends regardless, because it's either a 1, 4 and a 2, 3, or a 1, 5 and a 2, 4, and the 4 is not over here. So the 4 is over here. This is definitely a 4, so I can prune this down to 1, 2, 4, which is useful. And so that actually looks up and gives me the 4 and the 9 over there. This is a 1, 2, 3. It's not a 1, actually. That's a 7, 8 in some order. But I actually know these 2 3s are different, and these 7 8s are different, which I'm probably going to use to look down here at some point, I want to say. Right. So now this being 5 doesn't work, is what AFK is saying in I think a slightly different way, but it's if this is 5, now because the 4 is over here, this is 2, 3, and it breaks that cell. So this is 6, which means these are 2, 4. These are 1, 5, and we know where the 5 goes. And that's going to do a lot of damage to my assorted 5 marks, and place a 6 here. And place a 6 there while we're at it, and place a 6 there while we're at it. That 5 looks across and means that's not a 5. That 5 looks up. Makes that not a 5. Let's see. Yeah, but we like to do these things with less look ahead, and I think this was the correct time to get this done. Let's see. Oh, that 2, 4 looks up. Gives me a 3 there and an 8 there, which gives me a 2 there and a 7 there. Let's see. This is a pair of 2 and 7, and we actually know the order of those. This is not the X that has a 2, 8 on it. So this is, 1, 3, or 7, 9, and it matches the tentropy of that cell. I see. This is a little unappetizing to me, but I'm going to take it. This X, one of these two digits, has to go on this tentropy line, because that's what the tentropy line means. They obviously don't go in the same row, and this X isn't a 4, 6, so it goes there. But this one, you can see, can't be 3, 7, and it can't be 2, 8. So this is a 1, 9, is the only thing it can be. Let's see. So, oh, by the way, this is not 2 anymore, and it's not 1 anymore either. So that's a 3, 7. And therefore, this is now a 2, 8, which gives me the 9 and the 7, the 1 and the 3, 9, 8 over there. Let's see. These digits are a 1 and a 5, I want to say. Do I know the order on that? I guess I don't somehow. Let's see. Knowing what these are is going to be super helpful, I suspect. These are a 2, a 3, and a 4, actually. So that does tell me that this line needs a 7, and that 7 goes there, just by Sudoku. And it tells me that this needs an 8, and that 8 goes there by Sudoku, and so this thing is the 1 or the 9. And now the 2, 3, 4 need to go over here. That cell's not 2, 3, or 4, funnily enough. So that one's a 2, 3, and it's not a 2. So that's a 3, and that's a 2. This is just because 2, 3, 4 have not shown up on these. Okay, so that's a 1. Uh-oh, I broke it. Oh, no, sorry, I did not break it. 1 is on this line by Sudoku, is what I mean to say. Somehow I thought this cell just didn't deserve a digit today, apparently, which makes that a 9. Let's see. So these digits are just 7, 8, 9. And that one is the 7. These two are an 8, 9. That's an 8, 9 to finish off the column. This number is a 3. Let's see. So that's not a 3. Yeah, that could still be things. This is a pair, though, which consists of 1 and 5, which I don't think does anything for what it's worth. I do know that there's a 5 in here. AFK has a very nice observation, actually, which is that this total is no longer allowed to be 9 because that 3 there means I can't put a 3 over here, which would need to go with the 6. That's very clever. So this is a 7, which makes these a 1, 2, 5, 6. So those aren't a 1. So those aren't a 6. Oh, it wasn't even that 3. That's heartbreaking. This 3 was way cooler. Okay, so, right, so these not being 1, right, meant that these weren't 6, so I can de-6ify those cells, and, so this is not a 6. Yes, we do know now the total is 12 because we did the math before. And so that is an 8, a 9, and an 8. So these are just a 4, 8, because those are the digits that have not yet appeared in this film. So that makes that a 3. Let's see. This row is missing a 5 and a 1, funnily enough, which is going to resolve that this is the 1, 6. And so this is the 2, 5. But that's the 5. So that's the 2 and that's the 5. It's the 4 and the 6 and the 9 and the 1. 1, 4, 2, 5, 1, 8, 4. There seems to only be one digit left in this box, and I think it's a 4. 2, 4. Oops. 4, 6, 5. Go in over there. What a lovely little romp. And I think we can mark now. 3, 2, 6. 8, 9, 4. 7, 2, 8, 3. 5, 7, 3. 5 and 9 go into the puzzle. That was lovely. Huge fan. Oh, I did mean to heart that. I know it doesn't matter, but I'm going to heart it anyway. It definitely met the heart threshold. Excellent choice. Okay, let's have a look at other puzzle. Okay, let's look at a GDC puzzle. Apparently, there have been a bunch of these now, because this has the same constraint, actually, about not repeating digits on clue types. It's funny, I invented that constraint twice, because I set a puzzle with it, and then completely forgot that puzzle, and then came up with the idea and set another puzzle, and it was Glum Hippo who was like, I swear you had a puzzle with this exact rule set. And I was like, I really don't think so. But then I went and dug through the catalog and was like, nope, you're right. I did have a puzzle with this idea. All right, so all the same rules in this puzzle as the previous one. Although now our tentropy line is going to do a little bit more, because now we can sort of tentropy color these if we want. Let's see. What do I want to say here? So, yeah, the whispers all have to have a difference of exactly 5. I agree, because you've got to put the 4 with the 9, and you've got to put the 6 with the 1, and now you've just got a 7, 8, and a 2, 3. I agree. Yeah, there's a 5 in one of these cells. I agree that the 5 being in one of those cells tells me that this isn't 4, 5, 6, but that doesn't feel nice. I'll use it if I have to, but I'm not into it. Let's see. I am actually going to give these colors. Let's see. I'm trying to pick the most light colors I possibly can. I already did not color this correctly. Let's see. That is blue. I think it is cool as a deduction to have spotted, to be clear. I would not want it to be a deduction that someone deliberately put into a puzzle and expected me to find, which is a slightly different metric, I suppose. Let's see. This can be like slightly darker blue. I was trying to find a cell that saw all of the various black dots, but I could not. So if this is 4, 5, 6, then these are a 4, 6 pair. I guess it's probably worth writing in that the 5 goes down here somewhere. Yeah, I got there eventually. Once I ran out of space, I realized that something had gone horribly wrong. I'll use. I don't think it's going to do anything, but I'm going to use AFK's deduction because it is super cute. That if this is the 456 renbon, then we place a 5 here and we need to put a number that's 4 or 6 there. So in fact, the 5 is up there, so it's not there. Okay. And now this is either exactly 1, 2, 3 or exactly 7, 8, 9. Which sounds like it should interact with a 10 line, but it's not that kind of 10 line. Sadly, Chad, it's not a 10 line, it's a tentropy line, which is an entropic line, but for sums to 10. It's very funny, actually, that this puzzle doesn't have any X's in it. Like, the tentropy constraint doesn't really interact with anything in this puzzle. Let's see. Other than 5s, yeah, I suppose, yeah, that, let's see, I don't think there's anything too dangerous that we can make these German whispers. So I guess actually, here's the funny part. There's an odd digit on this black dot because there's definitely an even digit on both German whispers, and an even digit on the white dot is a hilarious deduction. So we know that this is either 1, 2, or 3, 6. Let's see. That feels very reasonable. This black dot almost can't be 4, 8 because of what it would do to the renbon. But it could still leave this renbon being 1, 2, 3, unfortunately. I do agree that does mean that this digit is odd, which pains me slightly to pencil mark, but I will agree with that. So this black dot always kills 2 combinations of German whisper. It is worth noting. And so it's the other 2 ways of making the German whisper that we use. So if this is 1, 2, for example, then we use the 3, 8 and the 4, 9. And if this is 3, 6, then we use the 1... that doesn't work. This can't be 3, 6. Because if this is 3, 6, then we need a 1, 6, right? Because we'd need a German whisper. Oh, no, sorry, that's not true. That's not true. But I do agree the 1, 6 whisper definitely is not here. But if this is 3, 6, then we use the 2, 7 and the 4, 9. There we go. My brain was having a really difficult time getting through that for some reason. Okay. So in fact, that's true. We always have to use the 4, 9. The 3, 6 breaks the white dot. Because basically, yeah, your basic argument is where does the 8 go in this box, I think. it has to go somewhere. And if it goes in either of these places, then it's a 3-8. And so the only universe where there's a 3 here, there's an 8 here. Except we said that if there's a 3 here, the 8 actually... well, the 8's going over here anyway in that instance. Oh, is the 8 just always on the white dot? I think that's the point. The 8 is always on the white dot because... Oh, no, sorry. I don't know what I'm doing 2 and 8 somehow going together. That's not how that works. I'm trying to frame this. If I'm going to use this argument, I want to frame it in a way that isn't I filled in every digit in the box and it didn't work. Which is the current status, as I understand it, of the argument. So, funnily enough, if this is 1-2, that does directly make neither of these Renbon 1-2. Or sorry, 1-2-3. So it'd make this one 1-2-3. Okay, I buy Emma's version that if this is 3-6, then we're ruling 1 and 8 off of these cells entirely. And so the point is now I've got to fill these 3 cells with 1, 8, and 5, and none of those white dot each other. I'll buy that. I like that as a way of framing this that is not quite as bad. So this is not 3-6. It is 1-2. So that means this does have to be 1-2-3, which means this does have to be 4-8. That one is 3-6. This is not 1 or 3. Let's see. Okay, so these I know are 3-8 and 4-9. So I know that's not a 9. My leftover even digit is a 6. So this is from 5-6-7. Right. This is now forced to be 7-8-9 because it doesn't have a 5 on it by previous work. So that is a 5, and we can do the 5 dance. Boop boop ba doop. Whoa. Boop boop ba doop. Whoa. Boop boop ba doop. Wee. Ba doop boo doop ba doop boo ba doop boo doop boo boo doop boo. Waha. Thank you, Zach. Thank you. So let's see. So this is 4-5-6. There we go. Like that. Okay, so right, those don't sum to 10 or anything like that. This tentropy is that tentropy. So I don't know how on earth I'm marking that, but I'm just gonna like put some circles there because there's a tentropy there. Yeah, that's right. This is a 6 and that's a 7. Maybe simpler deduction. But this is 1, 2, 8, 9. I could color the 1, 2. That is a good way of doing it. That's not the right color though. Very true. This digit is a naked 4. It sees 1, 2, 3, 7, 8, 9, 5, and 6. That might be like one of my favorite naked singles. In general, I think naked singles are a very bad thing to include in puzzles, but that is a very cute one. I like that a lot. One of these is a 3, and it's not that one. Because if that was a 3, that would be a 7. So that's a 3 and that's a 7. I see now that Chef of Death also saw that. So these are also from 1, 2, 8, 9, and this one's the 1, 2, and that one's the 8, 9. So that is a virtual 8, 9 pair. Let's see. One of these two is a 7. I do know one of these two. Sorry, I was going to say one of these two is a 3. That's definitely not true. One of these two is a 6, though. So there is a 6 up here. Oh, in fact, the 6 is placed. Where does this digit see a 6? Oh, wow. This is actually, it sees the 6 on the white dot. And that's actually coded. So this is a 6. I appreciate that that's secretly coded as a region into the error conflict checker. I definitely did not do that in any of the puzzles I set like this. So these aren't 3. And so these aren't 8 by virtue of how that worked. This column is still missing an 8, a 9, and a something else, and a 5. If this were a 5, that would be a 4. We do need an 8, 9 white dot. We have, and that's not the 8, 9 white dot because it would break this column. That could maybe just barely get away with being the 8, 9 white dot. Oh, that's not the 2, 7 one. This is the 2, 7 one. So therefore this is the other one. This is the 1, 6 white dot. There are 4 white dots. Not 3. Okay. See, this is not a 4, owing to that. Let's see. People are asking what this can be. So it can be 1, 2. 4, 5, 6, 7. And it can... Oh, right. Okay. So once you make the deduction that one of them has to be 8, 9, you can know... I see. Okay. So yeah. So there's 2 ways you can do this. One of them is to say you need a white dot to be 8, 9 because one is 6, 7. And I can't make 3 more white dots that don't overlap with 6, 7 unless I use 8, 9 because there aren't enough digits. And therefore, I know this can't be 8, 9. And so as soon as I see that the only thing it can be is 1, 2, or 7, 8, that already breaks. Or you can do the much cleaner thing that AFK did, which is to say one of these 2 digits is 8, and therefore this doesn't have an 8 on it. And so therefore this thing sees 6 and 8, and therefore is from 1, 2, 3, 4, but doesn't have a 3, so it's 1, 2. Anyway, that's the 1 and that's the 2. So that's the 3. Which gives me the 1 and the 2 up there if I fill in the right digits. Let's see. It didn't see 4 in a clean way, but I guess technically both sides saw 4. But that makes it, that sort of brings it into the same realm as the deduction that I was making when I noticed that. Okay, so yeah, so we've got one that's 3, 4, 5 and one that's 8, 9. Yeah, if you looked at odds, that made it cleaner. But you had to sort of look at an odd combination of odds and evens. Let's see. There's certainly a 7 in one of these 2 cells just by sudoku, which means there's certainly a 7 in one of those 2 cells by sudoku. Sure. Right. This sees a 1. So that's not a 1, so that's not a 9. In fact, yeah, there's a virtual 8-9 pair in this row. You can just point out because there's an 8-9 here and an 8-9 here. So this is never 8. So therefore, this is never 2. So this is 8 or 9. That's adorable. That's adorable. So this is a naked 5 because it sees an 8-9 pair. Lovely fist pump for that. That was great. So these are different 8-9s because of the tentropy line. So that's a 5, which makes that a 4. That's all anyone has really ever wanted to have happen in a Sudoku puzzle, right? Okay, so that means that's not a 4, which means that's not a 9. Yeah, that was great. So yeah, now this is the 8-9 Kropke that we promised existed. And so that is the 7, the 2, and the 7 over there. Let's see. Bye, missing deck. Let's see. This is a 4. Sorry, no, this is a 5 with an 8-9. I guess, yeah, this just is, no, this is that 8-9. What is missing here? And a 7. This is just a 5-7 pair is the things that are missing in this box. Okay. 1 in box 2 is placed by Sudoku, AFK points out. Very good. 7 now looks down this column at that pencil mark, placing the 7 on that pencil mark. Funnily enough, this 3-9 goes here. I'm not really going to pencil mark that, though. And not just because it annoys the ever-living daylights out of Tristan when I say I see this, but I'm not going to pencil mark it. There's a 7 up in one of those cells by Sudoku. This is a 4, 8, or 9. By virtue of the column. I see it's not a 4, so this is an 8-9. It's the other 8-9 for what it's worth. And so now this digit sees both colors of 8-9. So this is a 4 and that's a 9, which then makes this an 8 and a 3. And we can go through that. Very nice. We love it. We love it. Okay. Oh, I was supposed to use a corner mark instead of a colored bi-value coloring or whatever the formal name of the technique is. That's possibly true. 2, 3, 4. Okay, still need a 5 in the row and a 6 and a 9. Of those, that one's only the 5. Fills in lots of those things. Let's see. These are... one of them is a 3. I don't know which one. And then there's an 8, 9. Well, that one's definitely the 9. These are a 3, 8, and I don't know the order. I think I can probably hit mark now. Going 2, 5. Oops, I don't know why I was going to fill in a 7 there. Not for any particular reason. That one's not 1, 6. Let's see. That one's a 5, 7, 5, 6, 9, 7. Okay, we get all of that in there. Let's clean up a bit. The mark feature is a Chameleon plugin. I'm not sure if it's still supported. I think it is. But you have to go to Chameleon's GitHub page. If you ask on the Discord, someone will link you to it. That's a 4, 8, 9 triple, so that is a 7 and an 8 and a 5 there. It's a little bit tricky to install, and you have to be comfortable using Tamper Monkey on your computer. So it will not be for everyone, but I think it is it is very helpful as a wrapping up puzzles feature. Like, I'm sure we have done many more puzzles over the lifetime of the channel because of the fact that I sometimes use Mark. Uh, Alrighty. Let us take a quick break. At first, I thought you said there's even a Sven button that is Sven nicer, which I thought was cute. But then I realized I was just missing that. Yeah, the Sven button just sort of like is like, I'm done. I'm not going to actually do the rest of the puzzle. You do it. Uh, Alrighty. I am going to take a quick break, and I'll be right back with more puzzle time. So see everyone in just a moment. All right, welcome back. We have an adorable looking fog puzzle. I'm curious if it's going to continue to make a bear as we reveal the fog or not, but we will see. This is by Megan033. I can post a link in case Tristan has fallen asleep. All right, so these are odd. So they are certainly from 1379. Hey, ELSF, how are you doing? Hopefully this goes better than the last time you encountered a bear in a fog. I mean, the bear doesn't look too happy about it. Let's see. I mean, there are things that this just can't be. Like, this can't be 1, 2, for example. Because if it's 1, 2, then I'm obligated... Oh, I guess maybe... No, yeah, the 1, 2 doesn't work because... regardless of whether this is 1 or a 2, I need both things both places, because if this is a 2 and that's a 1, it doesn't work. And if this is a 1 and that's a 2, it doesn't work. 2, 4, I'm being told does work. But not if the 2 is there. Because if the 2 is there, I eat up all the low digits. Oh, no, sorry. Maybe that's... Sorry, I don't need to worry about eating up all the low digits. That's fine. 4, 8 seems fine. And I guess 3, 6 is fine, maybe? Okay, so maybe this was not worth marking. Hey, Mekti. Okay. 2 below 4 doesn't work. So there's only one way to make 2, 4 work. Okay. So I definitely need to make 2 strings of 3 consecutive digits, because this is basically 2 renban, if you want to think about it that way. And so what's left over has to be one of each mod 3 thing. So the remaining mod 3 thing, if this is 1, 3, the remaining mod 3 thing is a 2, 5, 8, basically always. Because we know that these are a 1, 7 and a 3, 9. So this is a 2, 5, 8. Do we know for sure it's not 5? Yeah, they're both high or both low. I agree with that. I used that in my proof that this was a 2, 5, 8. But I did not say it. You're right. But yeah, the fact that these can't be like a 1, 7 pair, which would allow this to get away with being other things. Okay, right. There's actually only 2 options, right? Which is why this is not a 5. Yeah, I did this more globally, but it's much smarter to think about what the 2 renbans are. So either these are 1, 3, in which case the renbans have to be 4, 5, 6, and 7, 8, 9. Or this is 7, 9, in which case the renbans need to be 1, 2, 3, and 4, 5, 6. So this is never a 5, because in fact one of the renbans is always 4, 5, 6. And it's not this one that's 4, 5, 6, because if this is 4, 5, 6, the 5 would go on the black dot in the middle. So this is the one that's 4, 5, 6. That's not the 5. And now this is 1, 2, 3, or 7, 8, 9. So this number here is the other 2, 8. However, neither 2 nor 8 go opposite a 4, 6. Sorry, go opposite a 6. So this is a 4. There we go. And we get to do a 4 dance. We got there. Thank you, Zach. Thank you. And now these are the other 1, 3, 7, 9. Okay. Okay, so this digit cannot possibly be even because it can't be 6 and it can't be 5. And it can't be 3-7 because we know it's next to a 3-7. So this is uniquely a 1-9, weirdly enough. Because we know one of these is a 3-7. And this number is also a 1-9, but for different reasons. This is a 1-9 because it touches 3 different digits within its box. And so that means it's a 1-9 or a 2-8, but we just know it's not a 2-8 by the column. So that's a 1-9. Okay, so what is left in this column, just for the record? We've still got a 5, a 3, and a 7, and a 6. Well, this one's not a 5, I can tell you that much. Oh, we could do some coloring. That's a good idea. So let's just make this yellow. So these are purple. But the point is that yellow lets me connect that that's purple. So these are both yellow. And if those are yellow, remember that makes these purple by similar. So that's yellow. Logic. Okay. So one of these 2 digits is a 5, because purple digits only border purple digits in 5, and I can't make both of these purple. So one of these is a 5, which removes the 5 there and lets me corner mark 5 in the column up here. For what it's worth. That means one of these is a 4-6, which means this one's not. For the record, because 5 is only adjacent to 4 and 6. So one of these is the purple 4-6. This, therefore, can't be the purple 4-6. This is definitely the purple 3-7. Right. That's very cute. Right. The 5 is not next to a 6. Because of the 5 6s above. This is super clever. So the 5 is next to a 4, which means, in fact, purple is low. So one of these is a 4. And so purple is low. Yellow is high. Hey, Juggler, how are you doing? Okay, and so one of those is a 5. That means this digit is a 3. That's a 9. 1, 2. Let's see. 8. Okay, so these are not 7, 9. These are not 1, 3. I really enjoyed your Minesweeper puzzles, by the way, Juggler. I'm 99% sure that was you. Okay, so these are a 5 and a other blue digit, which has to be a 1 or a 2, I guess. And these are both orange. Right. This digit can't be 6, because if it is, it makes this dot 5, 6, 7, which breaks that cell. Very cute. Okay, but now one of these is 6 for sure, regardless of whether this is 5 or 7. So that's not 6, which means this digit is a 6. Okay, so this is a 7, 8, 9, regardless. And it's only a 9, right? This is now uniquely a 9. Making that an 8 and a 7, just in terms of the fact that we've got all the high digits in the row. So this is low, and this is high. Let's see. I mean, this is a 2 or a 4, so it's just definitionally low. Let's see. There is a 9 and a 7. These are 4 6, or 8. That one's not an 8. This digit can't be a 4 because it's got a 4 corner mark looking at it. So that's an 8, a 4, and a 2. Wait, was that right? Sorry, no, that's not necessarily right. No, it is right. It is right, right? No, it's not. Sorry, it's not. It's not. It is true that this is not a 4. But it could be a 1. Yeah. I do know one of these two is a 9. Yeah, it does tell us this is not 1. So, okay, yeah. So it tells us this isn't 1 because it would make that 4. So now this is either 2, 4 going up to 8 or 4, 2 going down to 1. So this is always 1 or 8. Yeah, so this is an actual 2, 4 pair. Yeah, this can't have 1 on it. I agree with that. That would create way too many 1, 2, 5s in the row. 4, 5 actually also does not work if you look at it, because that actually creates too many 1, 2, 4, 5s in the row. So this is only from 6, 7, 8, weirdly enough. It's incredibly bizarre. 5 is just pointing over here. So yeah, so oh, sorry, it could be. Oh no, it can't be 5, 6 because of the 5 pointing. Somehow I skipped over 5, 6. So there's definitely a 7 on it. But yeah, the 5 pointing is the easier way to do this. So this is not a 7. It's also not a 6. So this can only be an 8 or a 9. Let's see. I know there's an 8 over here somewhere. I do know for sure that one of these is a 6. I don't know that that's interesting, but it's true. Oh yeah, if this is an 8, it makes that a 4. Right. The way this constellation works, if this is an 8, then that makes that a 1, 2, 4. Yeah, that does not work. I don't hate that. So therefore that's a 9. Now this has got to be just 5, 6, 7, 8. Just because it doesn't have a 2 or a 4 on it, so 5 is the smallest it can possibly be, and is also the only thing it can be. So that's a 6, 7, 8, which makes that a 1, 2, 4. Helps if I hit the right button, generally speaking. So these are 2, 4 now. Those are Orania. This is green. This is a blue 3. We'll just note. So this is either 1, 2, 3, or 4, 5, 6. Sorry, or 7, 8, 9. By the 4, 5, 6 here. So this is either 2 or 8 always. However, so this is always 4. This digit is a 4 regardless of whether this is 2 or 8, because it can't be a 1. So this is just a 4, a very strange 4, but it is a 4. I will accept that. So then the question is, where are 7, 8, and 9 in box 4? And the answer is I can't cram both of them in these two cells, and therefore I need at least 1, 7, 8, 9 down here. And if I make this a 2, I do not, in fact, get at least 1, 7, 8, 9 down here. So in fact, that these are the 7, 8, 9, with that being the 8, and these being the 7, 9. Which means that these are also 7, 8, 9. That being the 9. And therefore, these are also 1, 2, 3, and these are also 1, 2, 3, where that is the 3. There's my 1, 2 over there. These are my 5, 6 over here in some order, yet to be disclosed. These numbers are all high, or 5. I guess I can write in that these are 4, 5, 6, but that somehow doesn't seem super useful. Oh, I have a 6, 7, 8 triple in this row, so that makes that a 4. I see people in chat were talking about a 4, and it's like, what 4 are they even talking about? Yeah, this is not the 7 for the same reason that I know there's a 7 over here. So one of these is a 7. Let's see, what is this pair? It's a 1, 2 pair. Just by that. We've got a 6, 7, 8 in here somewhere. But probably I'm actually supposed to look at this. Okay, so 4 and 8 are gone. So this is certainly from either 1, 2, 3, in which case it's 2, 3 exactly. Or it's got a 6 on it, in which case it would have to be a 6 there with a 5 or a 7 there. And that one can't be a 5. So, yeah, this is either a 2, 3 pair or a 6 there and a 7 there. But this can't be a 6 because that would be a 3 in the column with a 3. So, in fact, these just are a 2, 3 pair. Making that 1 and 2. So this is 4 or 6, if we just look at the options, because it can't be 2, 1. And so this is not a 3, so it is 5 or 7, which gives me a 5, 7 pair in the row, funnily enough. And I'm sure some sort of 5, 6, 7, 8, 9 quintuple here. So this is indeed 5, 6, 7, 8, and 9. So this can't also be 6. So that's a 4 and a 2 and a 3 and a 5. Yep, the quint is also how I saw it. I assume it is not how the cleanest possible way to see it, but I'll take it. Okay, so now that makes that orange and green, which makes these both orange. Makes those 6 and 8. Let's see. That is a 1 by Sudoku. I probably know that this is orange, and a 7 by Sudoku. We seem to know that all of these are orange, and in particular, that one is a 9 by Sudoku. So all of these are blue. The last blue digit is assuredly on this black dot, because black dots need blue digits. So therefore, this digit is orange. Let's see, there's no high over there. Let's see, that has become a 5 somehow. Oh yeah, because of that 6. So we can make that a 5. I still need to someday learn how to actually set these. Yeah, that's a 5, that's a 6, okay. I was briefly confused because this Renban wasn't in order, but that turns out to be how Renban work. They don't go in order necessarily. So this is blue and this is green. We get the 5-4 and the 1-2 and the 3-1. These are 6-8. Let's see. These are also blue. I agree. This is just a naked 3, actually. So that's the 2. Let's see. These are a 5 and a bunch of high digits. These are 1, 2, 4. I see. So if these are 1, 2, 4, that means the only thing this black dot can possibly be is 3, 6. Which resolves this 8 and 6 over here. That makes this a 6, or I'm sorry, it makes this uniquely a 9, actually. Which makes that a 9. Let's see. We've got a 7, 8, the 5, 6, and a 4, 5, 6 winding up into some number of these cells. Let's see. What are these remaining digits? These are a 9, which goes here, and a 4, which goes up here. So these are a triple of 5, 7, and 8. I do have a Zackwing on 6s. Very true, right? Yeah, the 6s in column 7 and 8 are spoken for, so these aren't 6, so that is. And we have cleared all of the fog successfully. Okay, let's see. What is left over here, by the way? Okay, that's definitely not a 2. There's a 2 on this dot. So that gives me a Zackwing on 2s, actually, that now in column 7 gives me that that digit is a 2. 1 and a 4, which now gives me that this is a 5. So we get our 7-8 pair on the Renban. Totally fine. 2, 1, 2, 3, 1. Going in over there. This digit is uniquely a 5 because it sees a 7-8 pair. I don't know. That just tickles me every time. I can't help myself. So we get all of that over there. That 7-8 pair now looks down and makes that a 6 and that a 7, which then bounces through all of this to complete that. Blue and orange, 3 and 6. And I have to say, I love it when I finish the last clue and the grid looks like this. That is one of the things that makes a puzzle most pleasurable to do, is when finishing the last clue aligns with basically being done the puzzle. Sometimes you can't quite have that because of other reasons. So I'm not saying like your puzzle is bad if it doesn't do this, but it's a great sign if you can make it happen, which definitely did here. Great puzzle overall to... oh, I thought this was GDC. I said GDC. Did I just misattribute it? No, it's to Megan. Sorry. Oh, sorry. GDC was the last puzzle. This one is Megan 033. Got it. Sorry. There we go. Sorry. Apologies to Megan, but lovely, lovely puzzle there. I really enjoyed that. It did not turn out to look like a bear once you removed all the fog, unfortunately. Alrighty, let's look at... Let's look at this. Normal Sudoku variants apply by Half-Baked Lunatic, aka David Workman. So I think everything here is standard. We have no negative constraints or anything of that sort. We have some V's. I'm going to start coloring the V's and probably regret it quickly. But if you look at this, one thing you realize is that these are a 1, 2, 3, 4 quadruple. So these numbers are high and they're on black dots. So they have to be 6, 8 going opposite 3, 4, making these 1, 2. Let's see. All possible normal Sudoku variant rules have been given. Yeah, that makes sense. Yeah, we certainly have virtual 1, 2s because there's definitely a 1, 2 in purple and a 1, 2 in yellow. There's also a 1 in this cage, which probably means there can't be a 1 in this cage, but I don't know that for sure yet. Let's see. I do agree that these can't have 1 or that digit can't be a 1 or a 2. I agree. The 13 cage in box 8. Very nice. Very nice. That's the point. Thank you, Todd. So this being 6, 8 rules out the 6, 7 and the 5, 8 combination. So this can only be 4, 9, I believe. Which now means that this is either 1, 2 or 3, 6 only. This is uniquely 5 or 7. So there's a 9 on the outside somewhere. Let's see. So if this 9 cage doesn't have a 1, that digit is yellow 3, 4. This 8 cage definitely does have a 1, but I don't know quite what to do with it. I would tell me more if I knew both of these had to have a 1. Oh, in fact, actually, if this 9 cage is 2, 3, 4, that's yellow 3, 4. And therefore, that digit is exactly a 1. That feels like it's almost something. Like, it feels to me like that's probably adjacent to the correct series of deductions. So these aren't 1. True. Yeah, we certainly know that these digits are at most 6. These digits are at most 5. Okay, let's write in what these digits can actually be, and see if this leads us somewhere nice. So they're naturally from that by being on a black dot, but they can't be 1 or 2 because we've definitely used the 1 and the 2 in the column so far. So these are certainly from 3, 4, 6, 8. If they are 3, 4, then they're the other purple, yellow 3, 4. Oh, yes, 3 definitely doesn't work because if you make that a 3, then you have the misfortune of putting a 6 into your 5 sum and you don't have any -1s left in the row. So yeah, so each of these are from 2, 3, 4. Just based on that. No, they can't be 1. So one of these is 1. So that's not 1. And now we have the deduction I wanted. which is that the 8 cage has a 1. One of these is a 1. Therefore, the 9 cage doesn't have a 1. Therefore, the 9 cage is 2, 3, 4, and that is the yellow 3, 4 that this cage needs. So this is not the purple 3, 4, so this is the purple 3, 4. This is the purple 1, 2. We can come back over here. Yeah, this isn't 4 anymore, I guess. I don't know that matters. Oh, right. This is just 1, 9. It seems very relevant. I agree, Matt Laffey. It doesn't have a 2, 3, or 4 in it. Oh, right. The 2 is in here, right? One of these is 2. And so, therefore, that's a 1 and a 4. Got it. 1 and 4, 2 and 3. So these are 2, 3. That is a 3. Let's see. That seems to have become a 9 and a 1 in that order. That is a 1. Could probably lose the coloring at this point. That was a very nice break-in. I like that a lot. Okay. So yeah, so that's not 8 anymore. This is not 6 anymore. That one just is 8, in fact. This is a 7 or a 9. I still know one of these two is 1, but I don't think I know what I'm doing with that yet. Oh, I should probably fill in my row 9 dots. Very good. I can write in my 5, 7, 9s on the side. 20 Cajun 4 without 8. Yeah, it's got like a bajillion options. I don't want to think about it. Yeah, 1 and 2 are up here. Yeah, this being 2 or 6 actually restricts what this can be, because this can't be 6 itself anymore. And it can't be 2 itself either, so this is 1 or 3. I don't see the 3 part. Oh, yeah, I do see it, actually. Yeah, okay, yeah, so that's very, very surprising. So 1 and 2 are sudoku'd into these cells, but so is 3 by that 3. So these are a 1, 2, 3 hidden triple, which immediately makes the 15 cage 4, 5, 6. And I know that because one of the stupid Sudoku tricks that I've learned over the years is that if you have a 3-cell 15 cage, it is either 4, 5, 6, or has one each of 1, 2, 3, 4, 5, 6, and 7, 8, 9. Which is like one of those things that I feel kind of dumb for knowing, but what can you do? So there's 1, 2, 3 in the row. So everything else in the row is at least 5, 6, 7, 8, 9. This one can't be the 9 because that one can't be the 8. That one can't be the 9 because it would put an 8 in a row with an 8. That one can't be the 9 because that one can't be an 8. And so, in fact, the 9 is just placed over here, which, in fact, places that 9 over there, which I think is different than the way that other people were doing it, but we'll take it. These are a 7, 8 pair. These are a 3. Yeah. Sorry. That's the 3. And then this is another 5, 6, I believe. Okay. 9 is now placed here by Sudoku, points out SG. So now there is a 9 in my 20 cage. as well as a 1 or a 3. Let's see. This is a 5 or a 7, just for the record. So these are both 5, 6, 7. So that means one of these is 8, which in fact means one of these is 7, which in fact means neither of these is 7. Let me go over that again just so that we're clear. So one of these two is 8. The only digit that 8 goes next to is 7, which means one of these two is 7, which means that neither of these two is 7. But now that means like this one is not 5, for example, because it goes next to a 5 or an 8. Let's see. I don't know that I can quite make the same magic happen the other direction. Anyway, these digits are a 6, a 7, and a 5, for the record. Yeah, am I going to pencil mark this? Oh yeah, I might as well fill in this last digit in column 7. That will make AFK happy. It's an 8. Let's see. Yeah, I kind of both do and don't want to pencil mark all the possibilities for this 8 cage, because I do see there's only one way 1, 3, 4 possibly works, which is probably the solution. Oh, wow. Yeah, that's very weird. If this is a 2, it doesn't work, is what Josh is pointing out, because if this is a 2, it makes that a 3 and also makes this a 3 by the mechanism of making that a 6. So these can't both be 3. And therefore, this is not 3. Sorry, this is not 2. This is 3. Is the point. Right, yeah, this being 3, 2. That is a tris deduction if I've ever seen one. There's a 4 and a 5. Okay, so now this is 1, 2, 5 because it doesn't have a 3 in it anymore. It gives me a Zackwing on 2s at least. So the Zackwing on 2s sees this cell. And I think even AFK will grant that this is a Zackwing that is definitely not an X-Wing, given that it crisscrosses boxes. But that makes that a 6 and a 3. Let's see. Okay, so now we've got a 3 in this. So we've got only a few options. Let's see. Row 3, column 4, odd evenness helps. That's true. So now this is not a 6. Okay, and now... Oh, yeah, this could be a 6 and a 5. Okay, that's still possible, annoyingly. This is not 6, 7, but we already sort of know that. Oh, this 20 cage definitely has a 9 in it. By my Sudoku calculator, which pains me. This is my least favorite kind of deduction in all of Sudoku. But yeah, that's not a 9 and that's not a 9, so that's a 9, which gives us an 8 and a 7, 6 and 5. Let's see. Okay, so yeah, so these two add to 8. So that better not be a 4. So that better be a 6 and a 2. Not to disparage the puzzle overall, by the way. I'm very much enjoying the puzzle overall, but yeah, the look at these 18 combinations of this killer cage is not a genre of deduction that I usually use. But I'll take it because I don't know the setter well enough to know if the setter would have used it. Let's see, because I think this is the first puzzle I've done by this setter. Like, there are plenty of setters where if that showed up in their puzzle, I would just ignore it and just assume that it was going to get to the point where it was either minimized or maximized. These are 1 and 7. They're not placed yet, I don't believe. These are 3 and 8, and I don't think they're placed yet either. Good to know. This is super not 4-6, just for the record. The 9 in box 5 has been placed here. Has been pointed out. So one of these two is a 9, and it's that one, actually. Unfortunate, because that one being a 9 would have been more useful. Let's see. So there's a 9 in one of these two cells that could just barely make its way onto this X, I believe. Okay, this triple is 6, 7, 8. For what it is worth. I'm not wholly confident it's worth anything at the moment. There's definitely an 8 in one of these two cells. Let's see. Yeah, I know one of those is a 4. I already know that. These are 5, 6, and 7 as well, just for the sake of mentioning it. One of these two is a 1. Is it limited? I see it can't be 4, 6. Is there anything else it can't be? Column 5 does already have a 4. I agree with that. Okay, that's a deduction. These can't be 2, 3. So there's a 2 or 3 in this cage. And therefore, the one of the 2 3s is over here. And therefore, this is 7, 8, or 1. Technically all true. So this is a high, a middle, and a low, for what it's worth. Oh my god, that places 1 in the box. Or not quite. It almost does. It tells me 1 can't go in any of these cells. Because we know one of these is a 2 or a 3. And so, therefore, I can't possibly put another 1 in this white dot, because that would either put a 1 in the cage or put another 2, 3 in the cage. Can't put 1 there by sudoku, so there's a 1 over here, which now looks up and gives me this 7 into this 1. I feel like we have gone off the golden path here by following some of these observations. Let's see, Kurban says this sees the whole 8 cage. Okay, those are words I like to see. So it's not 1, 2, 3. I think it can be 4. It's not 5, and I think it can be 6, or 7 or 8. Let's see. Can't be 4 by white dot, because this would be 5. All right, there's a 5 over here in this box. Yeah, I hadn't actually noticed that there's a 5 corner marked in these two cells. So, right, so this can't actually be 4. I agree. So this isn't 5 either. So this is the other 6, 7, 8. And so now that's not 7. So one of these is 7, which then makes that a 5 and a 7 and a 1 up there. Okay. That's a 1 by virtue of the 6, 7, 8 triple. So that's a 9. That's a 1, 4, 9. Oops, we removed the 9 like 3 times and then it came back. Don't over-remove the 9. Okay, that 2, 5 pair looks down, making that a 3, an 8, and a 3. Let's see. Are we officially at mark, or do we want to note that this cage has a 2 in it first? A 2 and a 6, 8. It has a 2. It has no... Oh, it might have a 7. It doesn't have a 5, that's for sure. And it doesn't have a 9 either. So this is 2, 6, 7 is what this cage has to be. So that's the 8. That is not an 8. So that is an 8, and that's a 6 and a 7 and a 7. 2, 6, 5, 7, 6, 8. 7, 6, 4, 2, 6, and mark. If you Sven, by the way, it just goes whoop, and then the puzzle's done. But we can fill it in for real. You could just put a feature that just you just press the button and then it just tells you you've completed the puzzle no matter where you are in the puzzle. I really liked the opening of that. We got a little bogged down at the end there, but I don't have any reason to suspect that it was anything other than me taking suggestions that perhaps I should have been more disciplined about. Zackwing Unicode character, amazing. But yeah, very nice puzzle overall. Very nice. I don't think I've done anything by the screen name looks slightly familiar. I might have done a puzzle by Half Baked Lunatic before, but I'm not sure. All right, I'm going to take a quick stretch and we'll be back shortly with another puzzle. So see everyone shortly. Hello again. Welcome back. We're going to do this Yin Yang Yang puzzle by Nell Gwen that has Tapa stuff. And after we read the rules carefully, we're going to look at the example grid that is given. So we need to divide the grid into 3 colors, which are each orthogonally connected, and no 2x2 can be entirely within one region. So yin yang, but you've got 3 colors instead of 2. So we get to rediscover what things can and can't be true about yin yang with 3 colors. And then clues represent contiguous blocks of cells in the up to 8 surrounding cells that belong to a different region from the clued cells. So whatever the clued cell is, we've got sort of 5 contiguous things around it. But it can't be that 5 because I guess that would mean that these 3 were the same and that would create a 2x2. Okay. Each clued run of cells must belong to a single region, e.g. a clued cell in region A with a run of 2 cells in region B and 3 in region C would have clues of 2 and 3, not a single clue of 5. Okay, and then just so that we can look at the example completed puzzle here, you can see this cell is purple. And so we've got a 1 in blue, a 1 in blue, and a 2 in green. This cell is blue, and we've got a 4 in green and a 1 in green, etc. So that is our task. So I kind of want to start here. Oh, Tristan, can you put a link? I know Tristan is listening now, so I am off duty of copying links. So I know it's not the case that these are all the same color. So in other words, one of these 2 isn't purple. I feel like I'm probably going to be able to deduce something about this. Juan has gifted 5 gift memberships. Welcome to Lakia, Tristan, Rick, HK, and Juggler. Huge thank you, Zach, and huge thank you, Joel. Thank you. Happy 2026 to you as well. The problem, D-Web, is these 5 would be a different color, but then these 3 would be purple, and that would create a 2x2. Which is the reason why I said that was not going to work. Yes, but every color that doesn't match this is given. So the 5 shapes around are in a U shape, but I think that is just enough flexibility to not tell me anything about which cells have to be purple and which ones have to not be. So there's like a purple T, but the purple T could, as far as I can tell, go any which way. This is kind of interesting because there's a 3 and a 4 around it, and 3 and 4 mean that there's one cell from which this exits, and then every other cell is something different. Because the ones can be next to each other, it's complicated for me to process exactly what's going on with this, because like this could be orange. I don't know why I'm picking these colors. Then this could be yellow purple. Those would both count towards the 1. That was sort of my fear with that. Like if it were only 2 colors, I think you would have to do that. But because you can cram them next to each other, it doesn't quite work, I don't think. because you don't need things to separate them, basically. Well, the yellow would go like in that version. Oh, okay. So here's a statement. This cell is purple. Because if this cell isn't purple, then it would need to connect to its other friends, and in so doing would become not a 1. With the sole exception of if this is yellow and it's the only yellow cell in the entire grid. Can we cleanly and clearly note that this is not the only yellow cell in the entire grid? Because I'm absolutely going to assume it's not. And if I can't, but I'm curious if there is a clue that tells me right away it can't be. Yeah, the 3-4 clue needs 3 colors, right? Because the 2 have to touch, otherwise there's not enough, right? Yep, agree. So this is definitely purple. Okay, so this is where purple touches the border. And so all the places where purple touches the border have to be connected. Okay, so if this is not purple, then we escape out in this direction. Because we can't escape through there. But this could be purple and we could escape out like that, I think. We do know we've got sort of all the colors of the rainbow touch both of these, is the thing that we know. We don't necessarily know that all the colors do this here. That is true. If all the blue were on one side and all the yellow were on the other, the purple could touch in 2 places. But I think we basically know that's not true because of these 2, 3, 4s. Right. So whatever color this is, it can't escape this direction because it will get crushed, is AFK's point. So there's always a dividing line there. I agree with that. Oh, sorry. That was Juan. Sorry, Juan. And ditto this cell. Yeah, this only gets 1 cell in which to escape. Okay, I don't think I immediately know a checkerboard is fine as long as it's that kind of checkerboard. That kind of checkerboard is okay, but has huge connectivity implications. Because it means if this checkerboard exists anywhere in the grid, it means yellow and orange never touch orthogonally. But we don't know, I don't think, that yellow and orange definitely touch orthogonally as of now. Oh, actually, we do. Right? The 3-4 clues, right. The 3-4 clues tell us that yellow and orange touch orthogonally because the 3-4 clues feature all 3 colors touching all 3 other colors. Because the center color obviously touches the other 2 colors, but then the other 2 meet along an edge. So yeah, so we can't have any checkerboard of any kind. Even the sort of like mismatch kind. So yeah, so no checkerboards at all. That is true. Yeah, each color sort of behaves like an edge of the grid for the other two is a very reasonable way to think about it. Okay, purple can't make this turn. I am noticing. Because if purple makes this turn, then whatever this color is needs to escape. And that's a problem because it will create a 2. So purple's border in this direction can't make it further than here. Assuming that purple only touches the border once. But if purple touches the border twice, it definitely breaks the 2, 3, 4s, right? I think that's true. So yeah, so row 2, column 1 is only purple in the world where purple does this. Which doesn't seem likely, and in fact is completely disprovable. Yeah, that definitely doesn't happen. Because that makes this color, whatever it is, have to escape and definitely create a 1, 1, 1 there. Yeah, yeah, so... Oh, DWeb is claiming this cell isn't purple. Okay, let me try and explore that. So if this was purple, we'd know this was some other thing. That some other thing would not go there, so that'll be yellow. This can't be purple. Actually, maybe it even could be purple. But if this was purple, that would have to be purple, and then we'd need to do something over here, which is probably untoward. But certainly this wouldn't be yellow. But we're certainly going to end up with something like that, right? Yeah, I don't... unfortunately, I don't quite see this. I have strong suspicion that that would not work out well for any of our clues, but I don't know. But yeah, this does feel complicated. Yeah, purple wrapping around this side doesn't work. How far could purple possibly make it over here before we know that it has broken? And I don't even see any sort of easy way to sort of wrap to see that purple doesn't make it very, very, very far around the side. We do know for this 3-4. Maybe I should uncolor this for the moment. I'm just going to mark these as being definitely in the same region and uncolor this for a second and note that if this is purple, then we know none of these are purple. So these could be yellow, blue, for instance. Just by virtue of the fact that if they were purple, then the purple would not get out. This would also be yellow, blue by our earlier observation. Now, It does seem very difficult for these to not be all the same color, but I think it's technically possible. But one of these two, because the same argument you could make over here. Oh, Tristan never actually put the puzzle link. Maybe Tristan was less awake than I thought he was. There you go. So, can this purple really go down here? Maybe is a reasonable question. I don't think so, but I don't 100% see that it doesn't work. Maybe I should be looking at this one that's touching this 5 instead of this one over here. So these we all know are not purple. That one we know is not purple. And we know there is a U around here that is monochromatic of some sort. And that this is a different color from that U. Is there any way that this could possibly be purple? And unfortunately, I think the answer is yes. As best I am able to see it. Maybe I should think more concretely about what these two colors meeting actually looks like around this border. So we're doing something like that. Are there any sort of cute observations that we can make about how that interaction happens? It's definitely always I guess it's just by definition always sort of at one of these points because of the fact that it's sort of going to start there and then go 4 and 3 in each direction. Yeah, so because the purple is always on one of the compass points, the break is always between a compass point. And so, yeah, so that means the 3 is always taking up a full side. I agree. So it's always sort of two parallel sides that are the same. Not as each other, but that are the same. And then sort of a weird direction. Can the colors break at the edge of both 3 4s? I was thinking that might not be possible before, but I'm not sure. It might actually involve just thinking about this 1 1 1 a little bit more. Because I think we're like basically I think you probably can't do something like this. Yeah, you definitely can't do this by connectivity. In fact, actually, if you think about it, because the problem is the orange connects to the orange. Yeah, this is like a weird checkerboard, right? The orange connects to the orange, and that keeps this yellow on that side and doesn't allow it onto the other. So I'm trying to decide, like, how many colors can possibly exist here. So I don't think this works either, but I could be wrong. Maybe this works. Uh, uh, but the orange connecting to the orange is going to make it so that I feel like it's going to be hard with the 3/4s, but maybe not impossible. Basically, I want to say that there have to be that three of the ones are the same color, but I don't know that that's true because I'm not sure that this is totally broken yet. Uh, uh, but maybe. Like it doesn't feel good to me to have the yellow inside the orange, but maybe we're always stuck with that kind of thing. Okay, let's see. Emma is talking about the corner, the 5. Yeah, so Emma says this does not work because if we do this, this corner breaks because we have to invent a new color somewhere. Like we could go up here being purple. Breaks how? Uh, the 3, 4, and the purple. Right, because we know there's exactly 3 purple in one direction. And so now, yeah, now this purple gets out through there. Okay, so I agree. If that's purple, these are not the purple cells. And we know the purple cells are like that. So we actually are claiming this cell is definitely not purple. Oops. So this cell is definitely not purple, which means it's part of the U. So the U isn't this U. So yeah, it could be that, could be that. Let's see. Are there other purples that definitely break? Oh, I think Matt Laffey is right about this 3/4 business. Let me try and draw that. So so we've got blue, yellow, purple. So we know we have 2 points that look like this. And so if we think about it now, if blue connects somehow, and there's no purple that lives between the yellow and the blue ever again, because that would create a problem. And there's no yellow that lives between the purple and the blue. And so if I wanted to create this arrangement again, I think I would have problems doing that. Let's look at the example. So in the example, there's a 3 color point here, and that's actually the only one in the example, right? But I'm trying to make sure I believe that this is true of t's of any kind, even if I did something like that, that this still is a problem if I try and repeat this process again. And I think it is a problem. is if I try to do, let's just say I try and do it the other way up here. Then okay, so how do I explain this? Purple connects to purple. Yeah, so the purple here connects to purple, blue connects to blue, so we can make the statement yellow only exists between blue and purple. And therefore, that's going to be a problem because this is not going to be between blue and purple. Because you're going to have to enclose this yellow between the blue and the purple. Basically, any way you do it, you're enclosing that color completely inside that that module. So yeah, so that it is this, and yeah, I hazily recall doing a puzzle like this before, but yeah, and I think the point is the real edge also gets in the way there. Because in this version, all three colors, in fact, touch the edge, and we only get one of them. And so the point is that does mean this 111 needs to actually only involve two colors, because we have we have the two T's that could possibly meet. And so now this 111 needs to only involve two colors, and that had better look like this. Right? Because if I can't use a third color, I don't think I can do anything other than this. And now the entire border is yellow. That makes sense, right? Okay, and now I think now this cell has to be yellow. Oh no, it could not be yellow, and yellow could do that. Exactly. Like this cell certainly is not yellow. We can mark off with our yeah, this is not yellow, and it has to get out. Right. The 5 has to have a U around it. And so the U around it can't be yellow, because the yellow around this is definitely not U-shaped because of that. Right. Okay, yeah. So the 5 is yellow, and then this is the everything else, which could be purple or not purple. I don't know which. Maybe I should just draw it in as a line. But we can certainly border off that. And this is not yellow, so we can mark that is a true border as well. Okay, so the 3 here, I guess the 3 could be either one of these, right? Right. The 3-4 can't be the same as this, because the 3-4 and because this color only gets one cell on the border, so that does not work. This cell can't be yellow because then this cell is yellow by checkerboards is the problem. So if this is yellow, that yellow pulls the yellow over here by the no checkerboards problem. And then we have this issue. So in fact, the yellow really does stop here. Okay, and so then that's the 3, which makes this the 4. So we know this actually extends over to there, whatever color this is. But now this color just has to be the other color that's not purple, because this thing now gets out through here, and so is purple, I guess, is the way to say this. Okay, I would not want to have to make that whole argument rigorous, but we'll take it. So that's yellow. This is certainly not blue because it would make a 2 by 2. Uh-oh. Emma says I've already screwed up. It's broken? Oh, we have 2 triple points already. Oh, that's a problem. Why did we ever say this had to be... Oh, right. Oh, if this cell was blue, it wouldn't create a triple point. That was the issue. Is our argument about how this was arranged was about there not being any triple points, but that didn't actually force all of these to be yellow. It just forced all of these. Okay, so we have to restart. It just forced these to all be purple was our actual thing that we got, but we did not actually prove that these two had to be the same color, right? Yeah, we knew they were not touching. But yeah, it did not actually create anything in particular. But I think if we follow the idea that if these two are actually different colors, I think that breaks. So if I try and do something like this, I think that does create a problem involving, because I think that forces another triple point. But I'm trying to explain exactly why, because this is Matt Laffey's intuition, and I think it's right. So we'd be saying something like that doesn't work, right? So yeah, so this right. Okay, so here's the way to argue this, I think. So we'd need to have a purple over here somewhere. So let's just throw a purple there somewhere. Whatever it is. But now purple blocks off yellow completely from the rest of the grid. And so now yellow can't get over here to this place, which also theoretically needs a yellow, without bending in a way that squares don't bend. So I think, funnily enough, this might... No, it still wouldn't work. Yeah, this wouldn't work even if these were blobs instead of rectangles. But it's slightly trickier. But basically, yeah, I can't get this boundary ever again. So yeah, so this still works, I believe. That part of our argument still works. We can box in that, box in that, box in that. Yeah, the 5 still needs to be yellow because, again, if the 5 isn't yellow, then the thing that is around it needs to be yellow, but that doesn't work. So this is still yellow. These are still all the same thing that is not yellow. Okay, this thing now can't be yellow. We already knew it couldn't be yellow. I just erased that. We'd proven that long ago. And it's not that either because it doesn't have enough spaces. This 2 now certainly needs to be at least a 3 for sure. So this gets out this way and is hence known not to be yellow. But now yellow is a 3, and so now this thing is a 4. And so now we get that this is purple. And this is blue. Like that. We can still sort of box that in like that. Do we know that this is yellow, by the way? I don't know. Maybe I shouldn't think about that. Okay. This can't be yellow or it creates a third triple point. We know that. This can't be blue or it would create a third triple point. So it's yellow. Purple needs to get out because purple still needs to get to the other triple point. This can't be blue or it would create a third triple point, so it's purple. This... Oh, I guess I don't know because that wouldn't make a triple point. At least not immediately. Although if it was purple, it would certainly be a problem, I think. I think that has to be yellow, but I don't know a great way to articulate it yet. Okay, I probably should use another clue, huh? This 3-3 definitely can't be yellow, because if it was yellow, there wouldn't be enough room. So this is some other color. That means that the yellow is one of the 3s, and that is 3. So we've got to get this out. And so I presume that means it's blue, right? Because this certainly... I certainly know this is in a different universe than this. Because I need 3, and the 3 is always going to work that way or that way. Yeah, if this is yellow, I agree we get another triple point because we then have to put a 3 and a 1 around there. Okay, which means the yellow is the 3, which means we get actually that all boxed off. I'm almost positive this has to be blue and not purple. Right. Yeah, so this cell has to be blue is the way to see it, because this cell can't be yellow, and so we have to avoid the triple point. And so now this blue comes down here. We do that over there. Okay. I don't think we know for sure this side isn't purple. In fact, actually, maybe I think it's more likely that it's purple. As I look at this. This can't be purple or it's a triple point. I agree with that. Same here, right? We know this is not yellow, and so that's blue, which we know doesn't come here. And now here, again, that's still just blue. And there. Same idea. And so now we need our two ones to be separated. So these need to be our two ones. And they need to be separated by a blue, or we have a triple point, right? If the two ones are a yellow and a purple, that's just the definition of a triple point. So there's a blue there. Whatever this is, it certainly comes up like that. Or a blue 2x2, I guess, AFK, now that you mention it. I wasn't thinking that far down the line, but yeah, you're right. I don't think we can continue across our 8 because I don't think we know that cell's not yellow, do we? I think I can argue that this cell isn't purple, because I think if this cell is purple, this 3-4 clue is never getting a blue on it. So I think I know that this is blue. Because otherwise purple would have to somehow get here, and then that's, I don't know, maybe I don't 100% buy that. I don't know what you mean by borders. Blue doesn't have anywhere to go, right? Row 7 and 8 of column 2. Do we know that? Row 7, column 2, and row 7, column 3 can't be the same color. That would definitely be a problem. I agree. If these two are the same color, that doesn't work. So I agree that there is a line there. Right. And this can't escape that way because there's not enough room. So that, in fact, forces that, I see, and that, which does indeed create a border there. And now, right, now this needs to get out this way. Which does indeed border the yellow, and so now this is a this is the 4. This continues to grow up this way. It still isn't yellow, and if I make this blue, I create a triple point, so we can't do that. So that's purple. And now this needs to be a triple point, so this is blue. We can border that little bit over there. Okay, and so now this piece in here can't be yellow by connectivity, right? Oh, actually, sorry, maybe we could actually still get yellow in there. I don't know. This is blue to avoid a triple point. I agree with that. Oh, I do know that this extends over there. Right. If this is pink, then we've separated. No, that's fine. That doesn't break connectivity, does it? Okay, this 2-3 being blue doesn't work, or we create another triple. I agree. Good eye. So this is some color to be named later. So the blue is the 3 part, right? So the blue doesn't actually go there or there. So this blue needs to escape, actually. And does not, in fact, connect up like that. So now none of this stuff is yellow. Because yellow is now completely enclosed. So this is now purple. And now I have to be super careful about this. Okay, that's going to have to be blue. Well, this is certainly purple because that. Okay. Oh, so this is purple also. Okay, and and these are purple because of just the border, so that's blue. Like that. This blue needs to go on for 2 exactly, so that's blue and that's purple. And now we had better connect or we have a problem. And there we go. I feel like my brain still doesn't intuitively understand the whole triple point thing. Like I can kind of wave my hands and explain it, but I don't fully grok the triple point thing. But there we go. We got there eventually, one way or another. All right, I'm going to take a quick break, and I'll be back in a moment with another puzzle. So see everyone shortly. Alrighty, welcome back. We've got a 99% sneaky puzzle here with some standard constraints. And very conveniently, we have a 9 arrow given to us, so I appreciate that. My number pad was off because we did that. There we go. There's a 9, a 1, 2, 3, and a 1, 2, and we know that's not the 3. So the 3 is over there. Okay, so just for the record, this 10 cage is either 3, 7 or 4, 6. Oh, that's right. We got a digit. I didn't even notice. It was so generous. I didn't even notice. Boop, boop, ba-doop. Woo! Boop, boop, ba-doop. Wah! Boop, boop, ba-doop. Wee! Ba-doop, boo-doop, ba-doop, boo, ba-doop, boo-doop, boo, boo-doop, boo. Wah! Thank you, Zach. Thank you. DWeb points out that if this was a 6, these would be 1, 2, 3, and the 7 cage would be impossible. So this is certainly 7 or 8. Yeah, 7 also actually breaks it because you can actually do this as a like region sum lines trick if you want, or you can just notice that this being 1, 2, 4 doesn't work. But these things sum to a minimum of 15, so this needs to be at least 8, and so therefore it is 8. And so therefore these are 6, 7, 8, 9. These are 1, 2, 3, 4, 5, and we know there's no 1 in here. There is a 1 there for what it's worth. There's a 4 and a 5 hanging out over here. Let's see. Some 4, 5, some 4, 5 action. Yes. 3, 4 would break the 10 cage that we wrote in over there. Very good. So this is not 3, 4. It's 2, 5. So these are 1, 3, 4. So that's a 1. So that is the other 3, 4. So that, by the way, that gives us a 4 sort of running across the row. So there can't be a 4 in here. So one of these two is a 4, which means one of these two is a 4, which actually makes this 9 cage be 3, 6 cutely enough because it doesn't have a 1, 2, or 4 in it. So the low digit in it is a 3. 5 also needs to, 5 does also need to be on the quad, right? So I was like, I don't have a virtual pair involving a 5, which is true. I don't have a virtual pair involving the 5, but I have an other kind of pair involving the 5. Okay, so these are 7, 8. Okay, so there's definitely a 1 in one of these two cells. I should record probably just for my sanity. Let's see. Oh, these have just become a 2, 3 pair. Let's see. This is either a 1, 9 or a 2, 8. Which is maybe not that useful of an observation to make. That's a good point, right? Regardless, I definitely need 2 1, 2, 3s on the arrow, and this cell can never be 1, 2, 3. So this cell's definitely a 4, 5, and that 4, 5 goes here. Is Emma's point on that quad. And I guess goes there while we're doing 4, 5 things. Let's see. Yeah, so if I mark the other 4, 5, then this is now the spot for that other 4, 5 to live in that universe. Yeah, one of these is XE4, 5, but who knows which one. I assume this cage has a bajillion possibilities. It doesn't actually have a bajillion possibilities. It always has an 8 and a 9 in it, but that's not super useful, I don't think. Oh, does it never have a 1 in it? It never has a 1 in it. So yeah, the 1 looking over from these two arrows actually places the 1 there. Good spot. So that's not a 1. So that's not a 9. By the way, welcome, Sneaky. I hope you are having fun. So now this is suddenly at least 5. 1 is already in row 1, correct? So that's not a 1. So that's not a 9. And so, yeah, so that gets us an actual 2, 8, which actually does make this a 7, a 4. And so now we can sort of go through our 4, 5s. And then we can decondiment. A very important step after you condiment your hamburger is to remember to decondiment your hamburger, apparently. Okay. So That 1, 2 does indeed look right. It took me a second to figure out that you meant looks right as in going to the right, not looks right as in looks correct, which I was like, oh, good. I'm glad you think so. Let's see. The 32 gauge is forced now because it has a 4 in it. By sudoku, so now this cage is 4, 5, 6, 8, 9. And the 5 of that is there. So the 2 and the 5 over there. So no 5 in any of those cells, no 4 there. So one of these two is a 4, which in particular means that's a 4. So that's not a 4, so that's not a 6, as we bounce around the grid a little bit. Somehow, why do I have these all marked? Oh, there just isn't a 7 in the cage. I see. That's what's going on. 7 is not part of the whole process. Let's see. 2 in this box is here. Let's see. 7 in this box is there. 8 in this box is now in the cage, so neither of these is 8. Now those are a 6-9 pair, so these are a 4-8 pair. That was super nice. The 6-9 pair there is, well, I'm not trying to make a joke, but super nice. Let's see. Okay, so 3, 6, 9 up there. Make that a 5. And these a 1, 9. Which sorts out the 6 and the 9 right away, so I don't even have to condiment them. Okay, so no 9 goes there, no 9's there, no 9 there. Let's see. So we've got, oh, this is not a 3 because there's a 3 on this arrow. So this is 6, 9, and 5, I want to say. Okay, if this is a 5, then this is a, or sorry, if this is a 6, this is a 2, 4. Otherwise, it's a 3, 4, so it always has a 4 on it, I think. That sounds slightly messy. I don't know that I really want to do that with my life. Let's see, 7 in row 3. Good. So one of these is a 7. Yeah, I agree there's a 4 on this arrow, but I'm going to try and avoid it. Let's see. These are from 6, 7, 8, 9. It's messy in that you have to say, okay, the world where this is a 6 looks like 2, 4. The world where this is a 7 looks like 2, 4. So you've got 2 cases that split each into 2 cases and 3 cases. So you've now examined 9 cases to examine that in all possible cases there's a 4. It's not. It's like right on the edge, but it's past where the rest of the puzzle has been, which is why I am delaying it. But I will use the fact that the 9 doesn't go on the arrow. And ergo, this is a 6, a 3, and a 9. Which I guess Emma saw it the other way. Rather than the 9 in box 7, Emma saw it as the 9 in column 2. But both ways of those are like that. That's the kind of thing that I was hoping I would see, although I'm not 100% sure that it has still resolved the world. But let's see. We know there's a 2 over there. We know there's an 8 in one of these 2 cells exactly. This 15 gauge is kind of funny because I don't see how it could basically do anything. I mean, I know it's not 4, 5, 6. That is my total of what I'm willing to say about it. It has no 5. That's true. And so it definitely has a 4 or a 6, and we secretly know which one, but only secretly. Let's see. I do know there's a 9 in these cells, so there's a 9 in those cells. Yeah, it definitely does sort something out. It just doesn't feel like the right thing, but maybe I'll use it. The thing I was trying to avoid using was that this arrow, if I just write in all the possibilities, comes from 2, 3, 4, but I'll surrender and use it. This is the other 2, 3. Over down here. So these are a 6, a 7, and a other thing, and a 1. 8 is now placed here. Not quite do this. Okay, what is left in here? 3, 8, 9. That's not an 8, at least. We know the 6 and 7 in this column are down here, so I know that none of these are 6 or 7. So these are all from 1, 2, 3, 8, 9. So in particular, that actually does do something very nice, because that actually means the 4, 5, 6 that's in this cage has to be here, and it has to be the 6. I bet we could have done that first, and then it would have made the arrow piece cleaner. Because I don't think we needed, in order to notice that the 6 and 7 in column 6 were down here, I don't think we needed the deduction that we got with the 4 on the arrow. Oops. So now that's a 3, 4 pair, making that a 2. Okay, so this now has a 6. So these are, well, they can't be 2, 7, because again, we said the 7 was over here in this column. So that makes these 1, 8. And we can fill those in, making that an 8, making that an 8, 2, 1. Oops. Let's see. So those are 3, 9. Where is there even a clue? It's got to be somehow like this. Oh, this is a triple, so that would really help. So that's a 3 and a 2. Okay. Now that is my 9. Let's see. These are, let's see, we've got 1, 2, 3, 4. So then we've got a 5, a 6, and a 7 to place. I don't even remember when we used the 7 quadruple, I'll be honest. I'm sure we did, but I don't remember it at all. So now there's not a 3 or a 7 in there, so that's 4, 6. 2, 1, 3, 2. Let's see. That is a 1. These seem to be a 2 and a 7 in some order. Oh, apparently I do know the order if I look at my sudoku. And probably now we can mark. I didn't really want to mark just that one cell, I'll be honest. Let's see. 7, 5, 3, 6, 3. Lovely puzzle there. Great. Great work with the interactions there were quite nice. I enjoyed the chasing the 4 5s around with the 4 5 quadruples, and I enjoyed that these 4 5 quadruples were somewhat unrelated to this 4 5 quadruple, or at least mostly unrelated. But then you still managed to make them the same anyway, so that you had these sort of like the 3 7 quadruples and then the 4 5 quadruples, which is very nice. Alrighty. I think I'm gonna wrap up stream for today there. But thank you everyone for tuning in. Tristan will be back on Thursday with more Sudoku streaming, and I'll be back next Sunday with more Sudoku streaming. So huge thank you to everyone for hanging out. I hope you enjoyed our arrangement of puzzles. Zeta does that sometimes. He waits until he senses you've almost finished typing it to do it. That's definitely true. I definitely have a sort of psychic sense for, oh, now I can do the thing that I know that someone has been complicatedly explaining for 5 minutes of explanation. Alrighty, but I will see everyone real soon. Have a great new year. I'm going to go have some cheesecake after dinner to celebrate my upcoming birthday. So thank you all. I'll see everyone real soon. Bye for now.